Welcome to another episode of Terry's Notes. And I've been getting numerous requests to do past papers, but unfortunately, I am not getting sufficient time to do this. So this is my second video on your quick revision for the exam next week. Now, you are guaranteed to get a question on organic chemistry, and that is why I tend to focus on organic chemistry a lot. All right, so let's talk about organic chemistry. Now, whenever we are dealing with organic chemistry, we are talking about the chemistry of carbon, right? And there are certain things that you all need to know. You need to understand what is meant by the term homologous series. You need to know what is meant by the term functional group. Right? You need to understand what is meant by isomerism. Right? So these are terms that they tend to ask a lot in organic chemistry. So the first thing is homologous group. Right? Now, a homologous group is simply a group of organic compounds that have similar chemical properties, right? The physical properties vary, but the chemical properties are essentially the same. So for example, we have different kinds of homologous series, right? For CSEC chemistry, you need to know that we have alkanes, right? We have alkenes. Notice the difference in spelling here. We have alcohols, right? We have alkanoic acids. We also have esters, right? So these are the basic ones that you need to know for your exam. You also need to know the general formula of these different homologous series. For example, in the case of an alkane, the general formula is CnH2n plus 2. An alkene is CnH2n. An alcohol is CnH2n plus 1 OH, right? An alkanoic acid is CnH2n plus 1 COOH, right? Now, here's the thing. Whenever we have, let's say, for example, if we were looking at the alkane homologous series, so let's say alkanes, right? The general formula is CnH2n plus 2, right? Now, the first alkane that we have is methane, right? And the formula is CH4, right? In this case, N is equal to 1, right? So if we plug this 1 into the formula as N, we end up with C1, H2 plus 2 will give me 4. Then when N is equal to 2, we have ethane, which is C2H6. If we have N equal to 3, that is propane, which is C3H8. And we had to draw these things. So CH4 will look like this. Always remember that carbon can only form 4 bonds around it. So this is, we have one here, one here, one here, and one here. So if you draw a diagram and you draw more bonds around the carbon atom, just know that that is incorrect. Right? In the case of ethane, ethane will look like this. right? And then propane will have 3 carbon atoms, so that will look like right. So this is propane. So you need to know the general formula for the different homologous series. You need to be able to write the molecular formula. And when I say molecular formula, I mean like CH4, C2H6, C38. You also need to be able to draw the displayed formula as well. Now, let me show you something here. This is a typical examination question. They come and they give you some compounds, right? Some organic compounds. They give you this, let's say this. Let's see. And right. And the typical question could be, oh, sorry, let me give you one more example here. Right, so we have all these compounds, and they come and they ask you first to identify the functional group present and state the homologous series to which they belong. So let's start with this one here. This one, we have a double bond present, that is this bond here. So therefore we know that it belongs to the alkene group, right? The alkene is a double bond group, not alkane. The second one here, we have, this is our functional group, right? This is an alkanoic acid. Or this is an alkanoic acid. This one here, the functional group, is the OH group. So this is an alcohol. This one here, we just have carbon and hydrogen, and we have single bonds. So this is an alkane. And in this one here now, we have this functional group here, which is called an ester. Right? So typical examination question, they draw some diagrams for you and they ask you to identify the functional group to which they belong. Right? Make sure you understand these basic functional groups and have circled what the functional group are. So they can ask you to state what a functional group is, right? So a functional group is simply an atom or a group of atoms that determines the chemical properties of that particular homologous series. Okay, so make sure you have a definition for a functional group. You also need to have a definition for a homologous series, and you also need to give some properties of a homologous series, right? So here are some properties of a homologous series. All the members of the homologous series, they have the same functional group. They also have the same general formula, and they have similar chemical properties, right? But the physical properties, however, that changes along the homologous series, right? So properties of a homologous series. So the first one, they have the same functional group, right? 2, they have the same general formula. They also have similar chemical properties. Right? They also have physical properties that change change as n increases. And when I say n, I mean the number of carbon atoms. So the reason why they have the same chemical properties is because they have the same functional group, right? And also, this one is each member, or each member differs from its neighbor by CH2, right? So let's say we had let's look at the alkane functional group. So the first one will be CH4. Then we have C2H, 2 to 4, 2, 8, C3, sorry, this is 6, C2H6. This one is 8. Okay, so when we say they differ by CH2, so the first one is CH4, which is this. The second one is C2H6, which is this. So if you look carefully, the difference between this one and this one is CH2, right? And let's say the one with C3, okay, so in this case here, the difference between this one and this one again is CH2 units, right? Now, when we say CH2, we mean adjacent members of a homologous series. Just be careful with that, right? Because some people, they put CH2, but they don't explain what the CH2 means. It's adjacent members, right? Right, so it should be each member. All right, another thing to note is that as you move along a homologous series, we have a change in state. So like we may go from gas to liquid to a solid eventually, right? So as fast as we increase the number of carbon atoms, the physical state changes, right? Now, there's something else that you need to know, that is what is meant by structural isomerism. So we have structural isomerism, right? Typically they will ask you to define this, and basically we have organic compounds with the same molecular formula but different structural formula. So make sure you can give a definition for structural isomerism, right? So for example, let's say we have a compound like this. Let's say we have 5 carbon atoms here, right? Now the molecular formula for this compound is C4, and we count how many hydrogen atoms we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So C4H10. All right. Now, what if we have another structural formula here, and it's given by, let's say, just remember when you're drawing these diagrams, make sure you have 4 bonds around a carbon atom. Right? That's a common error that students make. They end up drawing their diagrams and they draw 5 bonds around the carbon atom. Right? So the molecular formula for this is also this is C5H10. Sorry, my mistake. So this is also C5H4. Right. 1, 2, 3, 4, 5, 6, 7, 8. Hold on, I made a mistake here. This should be. Yeah, sorry about that. I made a mistake. So it's C5H12, and this should be C5H12 as well. Sorry. All right. So these two compounds, they have the same molecular formula, which is C5H12, and their structural formulas are different. So therefore, these two compounds are said to be isomers. Right. Let's look at something else. You'll need to be able to state what is meant by a hydrocarbon. And a hydrocarbon, HYDRO, hydrocarbon, right? Hydrocarbon contains hydrogen and carbon atoms only, right? So that is what a hydrocarbon is, right? So if we have a formula that looks like C4H10, or we have something like C2H4, those are hydrocarbons. They contain the elements or the atoms, carbon and hydrogen only, right? You also need to be able to give natural sources of hydrocarbons, right? So natural sources of hydrocarbons. You can give natural gas, right? Also petroleum or crude oil, and also peat, right? So these are natural sources of hydrocarbons. So typical examination, explain what is meant by a hydrocarbon and give 2 sources of hydrocarbons, right? Now, you also need to be familiar with the fractional distillation of crude oil. Now, usually with crude oil is more valuable when we refine it, right? So what you all need to know is that you need to understand what the fractionating column is. So we have heat being applied at the bottom of the fractionating column, and what is happening is that we're going to have different fractions coming out from the fractionating column, right? So you have oil, crude oil here, and we have heat. And the principle upon which this is based is that the crude oil is a mixture of different chemicals, and each of these chemicals have different boiling points. So therefore, as you go up the fractionating column, the temperature decreases as you go up the column, right? So the hottest part of the fractionating column is at the bottom. So at the bottom you have bitumen. You get bitumen at the bottom. At the top you have refinery gas. Right? So your syllabus basically says that you need to give at least 3 fractions. So you can give refinery gas at the top, and we use that for cooking. And then right below refinery gas we have petrol, right? Which is really we use that for, so this is petrol here, and we use that for as a fuel in vehicles, right? In the case of bitumen, we use that for road surfacing and for fixing roofs, right? So you just need to understand the principle of fractional distillation of crude oil. So crude oil is more valuable if we separate it into fractions, because crude oil is a mixture of different chemicals, right? What you need to also know is what is meant by cracking. So we have cracking. Now, cracking, we need to be able to give a definition for it. So basically what it is the breaking up of large hydrocarbon molecules into smaller ones, right? And usually we get an alkene being produced as well. So we have 2 types of cracking. We have thermal cracking, and we have catalytic cracking. Right? In the case of thermal cracking, we're going to use heat to break up these large molecules. And in the case of catalytic cracking, we use heat and a catalyst. So that's the difference between thermal cracking and catalytic cracking, right? So let me give you an example. Suppose you have something like C5H12, and we heat this, we can end up with C3H8 plus C2H4, right? You see the C2H4? This is an alkene, which in the world of organic chemistry is very valuable, right? It is used as a feedstock to make other things in organic chemistry. Okay, so make sure you know what is meant by cracking. So cracking is a process by which we use either heat or a catalyst in order to break up a large hydrocarbon molecule into smaller hydrocarbon molecules, and usually one of them may be an alkene. Okay, so that is the definition for cracking. Just know that we have 2 types of cracking: thermal cracking and catalytic cracking. The difference between the two is that thermal cracking uses only heat, whereas catalytic cracking uses heat and a catalyst. Okay. One of the main things that you need to remember with organic chemistry, you're going to have to know the chemical properties or the chemical reactions that take place with these things. So let's look at alkanes, which is the first one. So I already stated that the general formula is CnH2n plus 2, right? And you need to know at least the first 5 members. So the first one is CH4, then C2H6, then C3H8, C4H10, and then C5H12. Right, so these are the first 5 members. You also need to be able to draw them, right, which is very straightforward. But what you need to know the chemical reactions for alkanes, right? So reactions. So the first one is they burn in air, burn in oxygen, right? So a good example is CH4, which is methane, plus oxygen produces CO2 plus water, right? Once you burn a hydrocarbon in air, you will always get carbon dioxide and water. So if I'm given any reaction for an alkane, we know that we're going to get carbon dioxide and water. Next thing you need to do is to balance this equation. So I have carbon here, one carbon here, one carbon here. I have 2 hydrogen on your right hand side, but you have 4 here. So let's put a 2 in front here. Let's check our oxygen now. So we have 2 oxygen on the right hand side plus another 2 here, which is 4. Therefore I need to put a 2 in front of this oxygen, right? You can review my video on balancing equations and writing equations. Right, so this is it for alkanes. They burn in oxygen. So they burn, what you need to know, they burn with a clean blue flame. This is important because when we do alkenes, you realize that they burn with a smoky flame. Right? So this is that's the first one. Second one is the substitution reaction. Substitution. Right? Now also you need to know that this reaction here is an exothermic reaction because we use natural gas as a fuel. Okay? Now, in the case of substitution, let's say we have CH4 plus chlorine gas, right? What we could get is CH3Cl plus HCl, right? That is just one reaction that you can get, right? You also need to know the conditions under which this reaction will take place, right? The condition for this reaction is UV light, right? Like I said in organic chemistry, you need to know the reaction conditions. So I'm taking methane, which is an alkane, and reacting it with chlorine gas. And there's a condition for it, which is ultraviolet light is required, right? So let me show you in terms of structural formula what is happening here. So we have CH4 plus chlorine. What is happening is that we are getting one of the hydrogen atoms from the methane is being replaced by a chlorine atom, and that is how we are getting HCl. So this hydrogen here is being replaced by one chlorine atom. So that's what you're seeing here, right? And in the case of chlorine could actually could replace several of the hydrogen atoms from methane, right? So there are multiple products that can be produced in this case, right? And well, we also already said that alkenes can be cracked, right? Could use thermal cracking. Now let's talk about alkenes. Now remember, I keep saying this is a quick revision. So alkenes, the general formula is CnH2n. The first one, which is C2H4, looks like this. What makes an alkene is because of the presence of a double bond. That is this, right? The next one will be C3H6, and that looks like this. When you are drawing alkenes, you have to be very, very careful, right? Because you must always have 4 bonds around a carbon atom. So let me show you a typical, what a typical student may do, right? Not all, but somebody might do it. So they will draw this here. And they might want to do this, but this is wrong. This is wrong. Why is it wrong? Because you have 1, 2, 3, 4, 5 bonds around carbon, which is incorrect, right? So you need to be very careful when you are drawing alkenes, right? So we need to know that alkenes are what we call unsaturated Saturated. Yeah, alkenes are unsaturated, right? And that is because they have a double bond, right? I forgot to mention that in the case of an alkene, see, so alkenes are saturated, right? Because they have no double bonds. So alkenes are saturated and alkenes are unsaturated. Okay? You also need to know that, and so the reaction, right? So the first one, they burn in oxygen as well. So if we have something like C2H4 plus O2 produces, again we'll produce carbon dioxide and water, H2O. We have to put a 2 here, we have to put a 2 here, and we have to put a 3 in front of this oxygen. Okay, so alkenes, they burn in oxygen, but they burn with a smoky yellow flame. So it's a smoky yellow flame, right? Something to note, this is a typical examination question when you are comparing alkanes and alkenes. Alkanes burn with a clean blue flame, whereas alkenes burn with a smoky yellow flame, right? Again, this reaction is exothermic, so energy is produced. So we know that alkenes undergo substitution reactions. But the thing is, alkenes, they undergo addition reactions, right? And there are several reactions that you need to know. So alkenes, they undergo addition reactions. Make sure you know that. Addition reactions. So let's look at the first reaction, first type of reaction, which is hydrogenation. Hydrogenation, right? In which case we have, let's say we have ethene. So we have this. Hydrogenation, we are adding hydrogen gas. So plus H2, and this will give me so if you notice here, we are producing an alkene. So if we have an alkene and we want to produce an alkane, we simply add hydrogen gas, but we need to use a catalyst. So we use nickel catalyst, and the temperature is about 200 degrees Celsius, right? So a typical examination question, they will ask you for the conditions, in which case the conditions are, we are using hydrogen gas, but we are using a nickel catalyst and a temperature of 200 degrees Celsius. These are things that you need to remember, right? So this is the hydrogenation reaction. Second one, we need to know, this is halogenation, right? And from your inorganic chemistry, a halogen could be chlorine, bromine, iodine. So let's say we have ethene again. We're going to react that with, let's say, chlorine. We're going to get an addition reaction. So what is happening is that a chlorine atom is going to add itself across the double bond. So if you notice what is happening here, the double bond is disappearing, and we end up with 2 atoms being added across the carbon atoms, right? In the case of an alkane, we had a condition. The condition was we needed UV light. In this case, we do not need UV light because the alkene is more reactive than an alkane, right? So in some books, you'll probably see the condition as you mix it in an inert solvent like CCl4, right? So the third type of reaction that you need to know is hydration. And that is simply the reaction of ethene with water or steam. Right? So in this reaction here we have ethene plus H2O, which is steam, really, gas. And that gives us an alcohol, which is right. What is important here is that you need to know the catalyst and the conditions. So we have an H3PO4 catalyst, right? And the conditions are 300 degrees C and 60 atmospheres, right? Now these conditions could vary slightly. So some books you might see 70 atmospheres and the temperature might be 290 degrees. So just stick to one. So typical examination question, how do you convert ethene into ethanol? Right? So it's a hydration reaction and we are using steam. The catalyst is a H3PO4 catalyst. The temperature is 300 degrees C and the pressure is 60 atmospheres. Right? What you get your marks for in this case here are given the conditions for the reaction. Right? Do another reaction here. Now another important reaction here, which is the fourth one we need to know, is the reaction with acidified potassium manganate 7 KMnO4, right? In this reaction here, this reaction is an oxidizing reaction, right? You need to know what is happening here. Now acidified KMnO4 is purple, right? But when it acts as an oxidizing agent, it goes from purple to colorless, right? Colorless, right? Basically the oxidation state so if in the case of the potassium manganate 7, the manganese ion, that is the Mn ion, is going from oxidation state +7 to +2, right? That is a decrease in oxidation number, so therefore the KMnO4 is being reduced, right? So the equation for this reaction is, so we have ethene plus, this is how you're going to write it, it's H2O plus O in a square brackets, that's from the KMnO4, and this produces what we call a diol, right? When we say a diol is because it has two OH groups attached to it. Right, so the product is actually ethane 1,2-diol, right? And this was ethene. All right, so you need to know this equation. You need to know that the KMnO4 goes from purple to colorless, right? Incidentally, that is a test that we use for distinguishing between an alkane and an alkene. So let me talk about that one time. Okay, so if we have an alkene, It's a typical exam question again, right? So if you have an alkane and we have an alkene, let's look at, let's say, ethane. Right, the alkene has a double bond. Now, typical exam question, you have to give a test that you can use to differentiate between the two. So the first test is add bromine water. What is that? Bromine